you have a function, a cubic function. Find what range of value of x whereby the dy dx means the gradient is negative. So before you proceed with the question, let's sketch the graph. Okay, now okay, now the y-intercept is 2. Okay, now let's since this is a positive x cube, so the graph would look somewhat like that. Okay, it looks more or less this shape. Now here may not be correct. Let's do some. Okay, now so assuming this is y equal to x cubed plus 3x squared minus 9x plus 2. Okay, now what is it? If you look at this graph here, you know when this negative, basically the tangent at a point is this way. If the tangent at that point, then the m is actually become negative. Okay, now if I draw a tangent at this point here, it's going to slant this way. So the m is actually positive. Okay, if I draw a tangent at this point, okay, tangent at this point touching the graph, this one, the m will be negative. So basically what it's saying is, wait, let's check where are the range of value x where the dy dx negative. Okay, let's look at the minimum point here. Okay, at this minimum point, the dy dx, the tangent is 0. And at this point, at the maximum point, the dy dx is also 0. Now, so these 2 points, the dy dx is 0. At this point, from here onwards, from this point onward, let's say this is x2. From this point onwards, if you draw any tangent, the gradient will be positive. This is not what the answer wants. Okay, now let's look at this, the maximum point here. If I draw a tangent, at this point, you can see that it's all slanting this way, where the gradient will be positive. Okay, now between this maximum point and this minimum, if you draw a tangent, you can see it's slanting this manner, where the gradient is negative. If I draw one here, it will be negative. If I draw one very near to the maximum turning point, it will be negative. So what it's trying to ask you is, let's say you have a maximum point where the x coordinate x1, where the minimum point, the x coordinate x2. So basically asking to find this value. This is from, if you have any x value from x1 to x2, okay, if you draw a tangent at those on the graph where the x is from x1, more than x1 and before x2, because at x1 and x2 the gradient is equal to 0, so it's not asking where the gradient is 0, so it has to be more than x1 and less than x2. So in this question, basically asking you to find this x1 and x2, so that you can put in the range of value. It has to be more than x1, has to be less than x2. That will be the answer. Okay, now before you so basically what you want to do is to find the dy dx whereby the gradient is 0. If you put dy dx equal to 0, that means you are looking and you solve that equation where dy dx is equal to 0. In other words, whatever value you obtain for the dy dx equation whereby dy dx is 0, whatever x you obtain from there, it will be x1 and x2. Okay, now so what you have to do is you have to find dy dx first. So it's y equal to x3 plus 3x2 minus 9x plus 2. So to find the gradient function, so with dy dx, 3x squared plus 6x minus 9. So this is the gradient function. Okay, now we want to find x1 at the turning point and then x2 at the minimum turning point. So what we want to do is we're going to find this value. So at this turning point, the dy dx is actually 0. So when dy dx equal to 0, so it's 0 equal to 3x2 plus 6x minus 9. Let's take out the common factor. 3x2 plus 6x minus 9. Take away the common factor, you got x2. Oh, sorry. If you take 3 away, this become 2x. This become 3. Okay, so finally the simplified equation is this. So let's factorize to solve the equation. So it's x minus 1 plus 2x minus 3. So it's actually minus 1 and x plus 3. Okay, now so therefore either is x minus 1 equal to 0 or x plus 3 equal to 0. So x equal to 1 or x equal to minus 3. Okay, so in other words, this point here is actually equal to minus 3. This point here is actually equal to 1. Okay, so find the range of value of x when dy dx is negative. As I explained earlier, it has to be more than x1 and it has to be less than x2. Okay, if equal to x1, then it will become 0. If equal to x2, the gradient becomes 0 at the turning point. So therefore the final answer will be x has to be more than x1, that means more than minus 3, and then less than 1. Okay, so any value you choose bigger than minus 3 or less than 1 is somewhere here. Okay, and if you find you can see that the gradient, you draw the gradient, the slope of the gradient is always slanted toward the left. Okay, it's slanted this manner, so it's always negative, which the question asks for. Therefore, the answer is this. This is the answer.